Okay, let's start. This is the week 2 part, supposed to be 3, but now kind of part 4. So we have learned the UML, which is a common notation. Common notations for the software design. And more like probably we can say that this is a standardized approach as well. Standard. But the thing is, knowing UML is like this. So this baby is reading a book. So probably he can or she can read the book and maybe understand it. But writing a book is a whole different chart, right? Charter. So what you have learned so far is reading this flow plan. So at this point, you should be able to implement that is designed here, right? So you can just read your flow plan or design of your software, and still is some kind of limited to some notations. However, reading and writing and designing it are completely two different things. Reading a text, foreign language, you probably you can use dictionaries and you can ask around the meanings of words, and probably and sometimes you can just guess the words. You can guess the meaning of the words, but and eventually you can comprehend what it says. However, writing a text in a foreign language is much harder, right? It's much harder because you don't know the grammar structures. And even though you know the grammar structures, you don't know what typical foreigners say their language, right? There are some typical idioms, there are common patterns of the word usage and so forth. In that case, you have to learn it. Same thing happens in the software design. Similarly, you have to learn the patterns of how they speak, how they design, how they draw their diagrams. So that's called design patterns, and that's what is happening in this part. Okay, for instance, let's say there is this case, a scenario of a software requirement. There is a customer and bank account. At this moment, you should be able to drawing like this. A customer has a bank account, and customer is should be able to access bank account. So it's going to be simple like this. This is called what? Association relationship. And probably one customer has many bank accounts. In some cases, one bank account holds 2 or more customers as the co-owners, but let's just say it's this case, right? And the customer uses an online banking service. Okay, there is an online banking service. And to use service, the customer should go through the online security check. 3 points. Login, transaction, and after transaction. So anyhow, you have to check this security. That's one big thing. And then at this moment, you should be able to imagine there is this case, there is a security checker, right? And the customer should be able to use it. This is what? Dependency. And this is like the engineer use calculator or something like that, right? And customer use security checker. And in that case, it is better to make a security checker class, right? It is too much to put a security check in a customer class, right? That's what we drawn so far. And then use the security checker class as the required points, right? And this customer class is a kind of big class, and what is happening here is the customer class is divided into 3 cases. Right here, the customer class also uses login handler and transaction preparation handler, transaction confirmation handler, and so forth. So this is also will be dependencies. And then this login handler also has dependencies to the security checker, right? And we have this structure. Is this sounds alright, and it will work alright? And the question here that we are asking in terms of the design pattern is that, is this an efficient design? Let's imagine this case. Next day, as always happens, the customer changes this scenario. So you are a IT consultant, you are consulting a certain company, and the company has this scenario, and you want to build, you have to design their solutions. In the case, you don't have to code it, but you have to design the solution package. And then you are going to draw the UML. And you will draw the UML like the previous ones. And the next day, the customer changes the requirements. And then you have to redraw it. And here, each customers belong to 3 groups exclusively. One is just the regular customer, household customer, and the second is the corporate customers, and third is the VIP customers, right? And the 3 groups have different security check rules, right? The household customers, they all have the personal registration numbers. Customers have all their business registration numbers, but it has a different system. And VIP customers, they have to go through a different security check. In that case, we have to have 3 checkers: household checkers, corporate checkers, and VIP security checkers. And each login handler will use these 3 different things. And because these are security checkers, they may have some common functions and data sets. In that case, the security checker will be here as a superclass. And these will be subclasses, right? Okay. Will work okay, and looks kind of alright, but there is one thing that bothers us. What's that? That is this. Awful lot of dependencies. Right? There are so many lines here. And if they add another customer type, you will have 3 more lines. Things like that. And if you have another function that requires security checkpoint, you will have to have the number of the customer types as the dependency links. So this will ever grow. Is there any solution to this? So here is a kind of solution. Because of these many dependencies, we are going to use a pattern called factory pattern, right? Factory pattern takes charge of creating instances. So this will provide customized instances from subclasses of security checker. Okay? And this login handler and transaction handler, transaction confirm handler will send customer types. And according to the customer types, this security checker factory check the customer types and will create instance by types. So this is 1, this is 2. And then what it does is that, and then returns return security checker as type, but the instance will be the subclass, will be the one of the subclasses, right? So you can read it. So return security checker as type, but the instance that will be returned will be one of the subclasses. So like this one, but the type will be this. Okay? Return the created instances by its base class type. Here, then what happens? Whenever there is a new function that comes in to use security checker, we'll add just one dependency, not like the n number of the customer types before. And it's, if you add another customer type, there will be one added dependencies like this, not like the number of the functions that use the security checkers in the previous case. Like in the previous case, we have too many. We have 3 by 3, right? This time we have 3 plus 3. And if the number changes, it's going to be 4 plus 3 or something like that. Here, if the number changes, it will be 4 multiplied by 3. 12 and 7. That's the power of the factorial pattern, right? So what we are doing here is that we are going to use these dependencies and associations and the how you call that it's tip of my tongue. Inheritance, right? Yeah, inheritance. You are going to use inheritance, dependency, association, aggregation. We have these words or these relations. We are going to use these wisely to cover, to implement software efficiently. Okay.